a rectangular piece of paper ABCD measuring 4 cm by 16 cm is folded along the line MN so that the vertex C coincides with vertex A as shown. What is the area of the pentagon ABNMD? Yeah? So let's look at a bigger diagram. Okay, we want to find the area of the pentagon ABMND, yeah, five-sided figure. The question is how to fold. Yeah? The first thing is you draw a straight line from A to C, draw the diagonal, and then find the midpoint. After you get the midpoint, you draw the perpendicular. MN is perpendicular to AC. Like that. Then you fold, then you will coincide. So let's label the diagram. Let this part be X. Therefore, the balance is 16 minus X. And the width is 4. 4 cm by 16 cm. Remember, this is perpendicular. So this side is AN is also X. Because we know AN is X, then we know the two angles are equal. Isosceles triangle. Then the rectangle must have parallel sides. So alternate angle theta equals to theta. This tells us that this triangle AMD is isosceles. Theta here, theta, isosceles, because 90 degrees. So you can label as X. If this side is X, this is X because isosceles triangle. Then the width is also 4 and 90 degrees. So here 16 minus X. Here so 16 minus X. So we use all this what called the length and form equation. We use the white triangle, Pythagoras theorem, triangle ABN. X square is the hypotenuse. Then 4 square is 16 and 16 minus X square. 16, expand the 16 minus X square. 16 square, 256. Then middle term, 32X plus X square. X square and X square cancel off. So 32X negative, bring to the left. 32X equal to 272. Then X is 8.5. So once we know X, we are ready to calculate the area. And what is a good way to calculate the area? It is sufficient to calculate the area of the triangle. And then we add the gray trapezium. The gray trapezium is half the rectangle. You fold into two like that. The area are equal, and the yellow and the gray area are equal. Okay. So the trapezium part that is 32 lah. 4 times 16. Area of pentagon trapezium is half the rectangle. So half times 64, 32. Triangle, half base times height. This is 4. X is 8.5. So 16 minus X is 7.5. Answer 47. Actually, before I do, I was like trying to save work. We know the area must be more than half. Answer half is 32. So plus the triangle more than half. So 17 and 27 out already. Half is 32. But got 3 number more than 32. So cannot know. Next question. Question 23. Train G passes a milestone in 8 seconds before meeting train H. The two trains pass each other in 9 seconds. Then train H passes the milestone in 12 seconds. Which of the following statement about the length of the trains is true? So draw a diagram. Obviously need a diagram. This is a track. M is the milestone. This is a railway track. Then the first train, G passed the milestone. So from here, it moved until here. So the end of the train is now at the milestone. So this is called past the milestone. Okay. Then the train G and H meet each other, passes each other in 9 seconds. Okay. So this is at the start where they meet. And then after that, train H is now on the left and train G is now on the right. The ends are just together. This one is 9 seconds. 9 seconds. Then the last part, train H pass the milestone in 12 seconds. So train H is slower. Take 12 seconds. Now, I label the time first. So we got 8 seconds, 9 seconds, and 12 seconds. In order to check the length, we need to label the length and the speed. So LG, length of train G, LH, length of train H, VG, speed of train G, and then VH, speed of train H. Now, the first part, we have the length is LG, 8 seconds, speed times time, 8 times VG. So it's length LG. For train H, time is 12. Speed times time equal to the distance moved. Now this part, when they pass each other, 9 seconds, the speed must add up. VG at VH times the time equal to the total length of the two trains. Total length, LG plus LH. Then the speed we add VG plus VH. Speed times 9 seconds is the length traversed in the time 9. This one we can explain so that it is clearer. Let me explain. Okay, train G and H travel in opposite direction. So we say this one is VG, then minus VH. Then we add, both add VH. So you add VH, then train H become 0. Speed becomes 0, so not moving. When not moving, this train G become faster, VG plus VH. Okay. Reduce to rest. G become VG plus VH. We move the whole system, move it towards the right, so that VH and VH reduce the train H to rest. Then VG will gain VH, VG plus VH. Then after they pass each other, we notice that I draw VH, train H still in the same position, not moving already. Then LG from here, the train, front of the train, come to here. So LH plus LG cover the distance, LH plus LG with a higher speed, VG plus VH. This is usually very confusing when I was teaching. I know many students take some time to understand. But one thing I like you to imagine also is the earth is moving. So if you are standing stationary, you are already moving, but you don't care about the rotation of the earth. You think your speed at 0, like that. See, you use the earth as not moving. So we use the train H as not moving to help understand why I want to reduce to rest. So we view as not moving, then this one become faster. If your father is driving and you are sitting beside your father, your speed is 0 relative to the father. Your car is moving, but your speed is 0 because you're always at the same position. The distance never changed between you and your father. But if your friend is standing on the roadside, you will see your car moving and your speed is not 0 already. Yeah, so it depends on relative to who. So this one relative to H, we make H 0. Relative to a father, you will make your father 0, then you're not moving like that. So that's why you add the speed. Then we substitute LG and LH from equation 1 and 2. 8 VG and 12 VH is LG plus LH. So after calculation, you notice that VG is faster, 3 times VH. Train H is slower, 3 times. Then we continue to calculate the length. So LG is 8 times VG. So 3 VH, 24. Then LH is 12 VH. So it's double, the length is double. LG is equal to 2 LH. So answer is A. Train G is twice as long as H. Okay, next question. The last non-zero digit of the number. This number, a lot of 0 at the end, a lot of 0 at the end because of 2 times 5, 10. So the last non-zero. After all the 0, what is the first number that is not 0? So we have 53 and 59. So we combine 2 times 53 times 5 times 2 power 53. Then we got balance 2 power 6 and 3 power 4. So 2 times 5 is 10, so 10 power 53. Then we want to have 2 power 4 times 3 power 4. So we have 2 power 2 outside. This is because we want the number to be 36. 36, when multiply itself 4 times, the number is always, last digit is 6. 36 times 36, it will have last digit 6. Last digit 6 times 4 will be 24. So you have 4 is the last non-zero digit, followed by 53 zeros. 53 zeros. In front, how many? We also don't know. Don't need to calculate. You just need to know 6 times 4, 24. Next question. Peter creates a kangaroo game. The diagram shows the board for the game. At the start, the kangaroo is at school S. According to the rules of the game, from any position except home, the kangaroo can jump to either of the 2 neighboring positions. When the kangaroo lands on H, the game is over. In how many ways can the kangaroo move from S to H in exactly 13 jumps? So the first jump must S go to P. Okay, after that, got 2 possibility, either library or school. So we show like this. School, go to playground, then X. X because I got 2 possibility, library or school. And then must come back to P. Cannot go back to H, game is over, So whenever P, then X. Whenever P, then X. X is either L or S. So X 6 times. You got 13 jump. So this S to P is the first jump. So 2, 4, 6, 8, 10, 12. And then last jump, 13 jump. So X 6 times. 2 times 2 times 2. 6 times 64 answer. Okay. Next question. You are given 5 lamps, each of which can be switched to on or off. Each time you switch any lamp, you change its status. Moreover, the status of exactly one other randomly chosen lamp is also changed. Always got 2 changes. You switch one on the one you switch off and one random. So for the same lamp, the choice of the other lamp may be different each time. Switch off A, it may be B. The next time you switch off A, it may be C. Maybe different lamp each time. At the beginning, all lamps are off. Then you make 10 such switch operation. Which of the following statement is true? This type of question regarding on and off, we say parity. Parity means either plus or minus or even and odd, usually like that only. The number is either even or odd. Sometimes it's either plus or minus. So if both lamp that change status, you switch off one, another one also change. If both that change status were off, then it become +2 on. Okay. If both that change status, the one you switch off and the other one that randomly, if both were on, then you can become off. So -2 on. So on increase by 2 or decrease by 2. If both have the same status, if both off or both on. But if one lamp is on and the other one is off, then there is no change because they swap status, the lamp swap status. On become off, off become on. So no change in the number of on and off. This means what? At the start, all lamps were off. So we conclude that the number of on is always even. At first, 0 on, all lamps off. So either 2 on or 2 off. Of course, at the second, at first all off, then will be 2 on. Second time, maybe both off become on again, or both on, then -2 on. So on always increase by 2 or decrease by 2. If one off, one on, then the number never change. So the conclude, the number of on is always even. 0 is considered even. Suppose you switch 2 times, on become off become on. And then again switch another 2 off and then become on. So become 4 on. Okay? And then you got now 1 off and 1 on. You may switch 2 on and then become less again. Or you may switch 1 off, 1 on, and no change. Now we want to check which statement is true and question asked, which of the following statement is now true? The first one, it is impossible for all the lamps to be off. True or false? All lamps at the start is off. Then after a while, can all be off? False. 0 on is possible. So it's possible for all lamps to be off. No on, no on means all off. So possible, possible. So statement is say impossible. At the start already all off. You switch second time, maybe the 2 on become off again. Possible. So you say impossible. So false. Then all lamps are definitely on. You say false because when all on, the number on is odd. We already say number on can never be odd, always even. Number on or even. So if all on, then 5 on. 5 is odd number. You cannot, must have even. So false. Third statement, impossible for all the lamps to be on. True, because cannot have all on. So impossible to have all on. All on is 5. 5 is odd. So impossible. So true, impossible for all lamps to be on. Then this one is the one that is tricky. All the lamps are definitely off. False. All lamps can be all off. But the word definitely, not definitely, can be all off, but not definitely. So that's why it's false. Okay, you can have 2 on, then all lamps definitely off. False. So none of the statement A to D correct is false because C is true. C is true. So this is false. So that's how you must realize it's a parity question. Odd or even one. They all I ask in different ways. 6 different positive integers are chosen. The biggest of them being n. There exists exactly one pair of this integer such that the smaller number does not divide the bigger one. You got 6 integer. You want one pair that smaller does not divide the bigger. Only one pair. 6 integer can be how many pair? You got 6. You want to choose 6 choose 2 lah. 15 pairs. 15 pair, 14 pair, all got divisible. Must have one pair exactly. Exist exactly one pair, not possible. What is the smallest number possible value of n? So these are the answers. N, can it be 18? We look at all the numbers given. Then we look at all the factors, because then only we can have number that divide each other. Smaller number divide the bigger number. Like 1 divide 2, 1 divide 3, divide 6, divide 9, divide 8. 2 it cannot divide 3, can divide 6, cannot divide 9, the 18. So 18 definitely not the answer because 6 factors only. 6 factor, you can form 15 pairs. 15 pairs, you only want one pair that does not divide one. So we already can have 2 pairs. 2 cannot divide 3. 2 cannot divide 9. Cannot like that. So let's list down how many pairs. 20 also got 6 divisor only. 1, 2, 4, 5, 10, 20. You choose maximum, you can get 15 pairs. Then you can already see got pairs that more than one pair. 2 cannot divide 5. 2 cannot divide 5. And then 4 also cannot divide 5. 4 also cannot divide 10. So many pairs. You want only one pair. So 20 also cannot because they got too few factors. They only have 15 pairs. 24 is 8 factors. 1, 2, 3, 4. 1, 2, 3, 8. 8 choose 2. We can have 28 pairs. But we want only 6 numbers. So we can avoid all that cannot divide one. There are many, but enough to throw away because we have to choose 6 different numbers. So here got 8 numbers. You only want 6. So we look at the 18. 2 does not divide 3. 2 does not divide 9. 6 not. Out of 15 pair, 3 pair. So out already. We only want exactly one pair. Then for 20 also got 3 pairs cannot divide. So left 12 pairs only cannot. We want exactly one. Now we look at 18. 18 so got a lot. 2 cannot divide 3, 3 cannot divide 4, 3 cannot divide 8, then got some more ... But we got 28 pair. You throw away 3, we still can have 6 numbers. Out 8 numbers, you can still look for 6 numbers, 15 pairs, where one pair cannot, exactly one pair cannot. So you will see why I write 15. If you want 15 pairs, you will see why this help. You'll see the working first. So we are using the 24 one. 1 divide 2, 1 divide 4, divide 6, divide 12. Got 5 pairs. 5 pairs. This 2 can divide 4, can divide 6, can divide 12, can divide 24. So 4 pairs, 5 plus 4. Then if we come to 4, 4 cannot divide 6. 4 can divide 12 and 24. So got 5, 4, 2. 5, 4, 2. Okay. And then 6 can divide 12 and 24. So can 2 pairs. And 12 divide 24, 1 pair. But if we look at the 1, 2, 8 one, 1, 2, 4, 8. First one, 5 pairs, 5. Yeah. Then 2 divide 4, 8, 12, 24, 4 pairs. 4 can divide 8, 12, and 24, 3 pairs. But then 8 cannot divide 12. 8 can only divide 24. So one pair only. Then 12 divide 24. Then 1 pair. So these two are the answers, These two are the answers. Let's see. Okay. This one got 5 pairs. The second one got 4 pairs. And then 3 pairs. And then 1 pair, 1 pair. And then 8 cannot divide 12, 0 pair. Okay. You can count. One divide all the other 5. 2 divide all the other 4. 8 divide the other 3. 4 divide the other 3. Then 8 cannot divide 12, but 8 can divide. So 1 only. 12, 1 only. So that's why I write 5, 4, 3, 1, 1. 5, 4, 3, 1, 1. Then the last, the 0. Exactly 1 pair cannot divide exactly 1 pair. So I show the answer like that. 5, 4, 3, 1, 1, 0. If you look at the second case, I'll write down all the 15 pairs. 5, 1, 1, 1, 1, 5 pairs. The first one. Then 2, 1, 1, 2, 3, 4. Okay. Then 4, 1 got 4, 4, 4. Then 8 got 1 only. 8 got 1 only. Then 12 got 1 only. So got 1 pair. 8 cannot divide 12. So that's why he say 6 numbers. 6 numbers, sure, 15 pair. This one, 14. Add up 14. So 1 pair cannot. So total 15 like that. If we take the 1, 2, 4, 6 one, okay, 5 pair, 4 pair, then 2, 2. 2, 2, 1. 5, 4, 2, 2, 1. This one is 5, 4, 3, 1, 1. So got exactly 1 pair cannot divide. 4 cannot divide 6. That's all only. So I write down all the pairs just to make sure you all have clear understanding of what the question is talking about. So one with 2, 1 with 4 until 5 times. Then 2, 1, 4 times. 4, 1, 2 times only. 4 cannot divide 6. 6 one also 2 times. And 12 and 1 time. So 5, 4, 2, 2, 1. So got 1 pair cannot. So answer 24. The smallest. You want the smallest. We already found the answer 24. So 36 and 45, no need to do already. They are bigger. What is the smallest possible value of n? Must be 24 lah. No point do all this tedious what you call tedious listing. Very tedious. Number 18. Nick wrote down all 3-digit integers, and for each of them he wrote down the product of the digits, and Nick found the sum of all these products. So there's a lot of product, and it add up. What total should Nick obtain? So to do this, we must like order make some order listing. So I start with one digit one. So I start 1 1. So 1 1 1 1 1 2 1 1 9 up to this. Then find the product. Find the product means 1 times 1 times 1, 1 times 2, 1 times 2 until 1 times 1 times 9. So you get 1 plus 2 plus until plus 9, 45. This one is the first digit is 1. Second digit also 1. Then we go to first digit 1. Second digit is 2. Then become double already. 1 times 2 times 1. 1 times 2 times 2. So double. Instead of 1, 2, 3, 4 up to 9, then 2 times 1, 2, 3, and 1, 2 until 9. So double answer. So by this reasoning, if we go to 191, then it will be 9 times. Because 1 times 9 times 1 all become 9 times. This one is 1 times 1 times 1. Yeah, 1 times 9 times 1. So every term 9 times. So the sum is 9 times 45. Then we add up all this. Is only for starting digit is 1. So sum of product with first digit 1 only. Got a lot more. First digit 1, we have 45. Then 2 times 45 until 9 times 45. 1, 2, 3 until 9 times 45. So this is also 45. 45 times 45, 45 square. For digit 1, I put 1 times 45 square. So for digit 2, this one is 1 to 9. Digit 2, the first digit now become 2. All will double. So become 2, 4 until 18. So 2 times 45 square. Will be double. Those with digit 1, first digit 1. This one first digit is 2, double. The first digit is 9, then will be 9 times. So become 9, 18, 81. Like that. So you add up for all. So again, 45 times 45 square. 1 to 9, 45 square. So 45 times 45 square. 45 cube. So what you learn from this question is you at first must try to see what kind of order you will choose. So the order is quite natural. Choose digit 1 first, and then choose second digit 2, 3, 4, 5, 9. Then after that, first digit 2, and then first digit 9. I think you know what I mean. Okay, we go next question. The numbers from 1 to 120 have been written into 15 rows. Okay, there are 15 rows. In the manner indicated in the diagram, for which column, counting from the left, if is the sum of the numbers largest. So you will add the column. Which column? Column 1, column 2, column 3, all will have different total, different sum. Which column is the largest? Is it column 1, column 5, column 7, column 10, column 13? If column 15, only one number, last number. Column 1, 15 numbers, allowed number, but the number smaller. For second column, the number bigger, but less one row. So are we going to add? Are we going to calculate every column? We try not to. So we write down and hope to see some pattern. If there are 15 rows, then there are 15 columns. 15 rows, because you see a square, half a square, 15 rows, 15 columns. You can see when it's 5 rows, 5 columns. Okay. So it's very important. Then we calculate column 1. We don't calculate, we just write down the number. 15 terms all got 1, 2, 4, 7, 11, 60, 106. Then we write down column 2. Column 2, I want to have 15 terms, so I put 0 at the start. Column 2, the first number blank, so put 0. So all 15 terms, like that. Column 3 will have 2 zeros, and it start with 6, 9, 13, like that. Last term is 108, given the last row, they give all. Column 4, 3 zeros. Column 4 is this one, 3 blank on top. First number is 10. And column 5. So we now try to see how to get some pattern to help us know which column is bigger. We can see that column 1 is smaller than column 2. How to see? We don't want to know the total. We add up, we can know. But without adding, then we can see, here increase by 1, 3, 2, 5, 4, 8, 7, 12, 11, 107. There are 15 columns. 14 times 1, 1, 1, 1. Only one time is 1 and 0. So obvious C2 bigger than C1. Okay. 14 times because one term in the front there. If we look at column 3 and column 2, we know column 2 bigger already, so we check column 3 bigger or not. So again, it got 6 more than 5, 9 more than 8, 13 more than 12, 108 more than 107. 13 terms, So 13 times, only lose out 3, 3 lose to 0 lose to 3. So win 13 times. So C3 bigger C3 bigger. Then we look at C4. C4 got 12 terms. 3 terms 0, 3 terms 0. Altogether 15 terms. We know 15 columns, 15 rows. So 12 times 10 more than 9, 13 more than 14, 12 times all, 109. Only lose 6. So C4 bigger, like that. Let's write down what I say. If 14 times bigger, but lose 1 time minus 1. So bigger by 13. The total is bigger by 13 without having to calculate the sum. We know it's bigger by 13. You want to know what is the largest only, not the value. The second one, 13 times bigger, but minus 3. You got 3 more than 0. Okay. Then 12 columns. The front 2 0 lose out. The rest, column 4. Column 4. 12, 12 times bigger. Lose out the 6. Lose the 6. Okay. Then this one, C5. 4 terms 0, so 11 times bigger, 11 times 11. Then lose out the 10, so 1. Then you can see that the next one is going to be negative. You notice that here is always 16 one. 2 plus 14, 3 plus 13, 4 plus 12, 5 plus 11. So 6 plus 10. We know it's 10 like that from the pattern. You don't want to write out already. Then this column very easy to know because it's always the diagonal 1, 3, 6, 10, 15. Always the extra one. Always the extra. So therefore, column which has the largest sum, column 5. 5 is bigger than 4. After that, 6 is smaller already, negative already. The answer is B. Answer is B. So you may say, sir, like that, 15 column, you can still do like that. Suppose I say 30 column, 30 rows or 100 rows, then different already. So I try to do general case. First, I noticed that the diagonal 1, 3, 6, 10, 15. This triangular number, this one called triangular number. The number form triangle. So the second term is 1 plus 2. 6 is 1, 2, 3. 10 is 1, 2, 3, 4. So we want until n minus 1. Because this is n, the front is n, the second is n minus 1. So the n term is, number of term is n minus 1. Front first term plus last term is n over 2, n plus 1. This is the n term. So for 15 rows, then we have 16 minus n. Like here, 16 minus 2, 14 like that. Then here, n minus 1 over 2. So if we check n is 15, then we know 16 minus 15. Okay. So 15 times 14. So 1 minus 105, negative 104. This is the last 2 rows. So we can easily write out the last two rows. Row 14 is, because row 15, 106. The number will be 105. Then only jump to 106. Then here 120 is the last number. Second last number 119. So row 14, you add these two. Row 15 minus row 14. Column, sorry. This is column. Column 15, 120. Column 14, add up is 224, 104. So the formula is correct one. You see, so now if they put 100 rows, then you put here 101. Okay. General case lah. Actually finish the problem lah. I extra hardworking only. Go and do. Want to show lah that the last two row we match the answer. Because you can calculate the total, only very few number, one number left only, and column 14, two numbers only. Okay, one more question. Let A, B, C, D, E, F, G, H be 8 vertices of a convex polygon. Convex means all less than 180 on the angle, internal angle. The point cannot come inside. They cannot B and C, D. It's concave already. The point all, the angle is less than 180. And so we have randomly choose from C, D, E, F, G. Okay, 6 vertices only. C, D, E, F, G, H. And draw a line segment connecting it to A. So you join to A. Then you also do once more. Randomly choose from the same 6 vertices. And now draw a line connect to B. So you draw 2 lines only. First time you choose 1 out of 6, join to A. Second time you choose from the same set, C, D, E, F, G, H. Then you join to B. What is the probability that the octagon is cut into exactly 3 regions? Okay. So again, this fella like to next question on ordering on how to order your cases. All the cases are not easy to calculate in general, so you need to see a pattern. So we start with one. If we got 6 choices to join to A, C, D, E, F, G, H, B not included. You choose join to A. So this you choose one only. Then after that you join to B, also got 6. You choose one. So total 6 times 6. You choose one for A. There are 6 choices for B. Choose a second one for A. Another 6 choices. So 36 ways. For each segment with vertex A, you can draw 6 with vertex B. Total 36. Total 36. We list pairs that make 3 regions. If I join AC, join AC, I show the segment. Then I get 0. I don't get any 3 region. Number of region that make 3 region one don't have. Because if you choose now I want to join to B, all will cross. If you show, all of them will cross. Once you cross is 4 region. Once you cross is 4 region, 1, 2, 3, 4. So for AC, no region, no segment that make 3 region. Now we do second one, AD. AD, we want to have 3 region. All this side sure cross one. You join to B sure cross one. So only one that don't cross. BD, only one segment don't cross. Like that. 3 region, 1, 2, 3. The rest will cross. Then we go to AE. AE, only can join to BD and BE. On this side, all will cross. So 2 only. Now we can show this one can, or this one can. Then we go AF. AF can have 3 points, BD, BE, BF. 3 segments can make 3 region. Okay, I think I don't have to show already. 1, 3 region. This one, 3 region. This one, 3 region. So then finally AG. AG, you can AG 4 region, BD, BE, BF, and BD, BE, BF, BG also can, BG. 4 segment, BD, BE, 3 region, BF, 3 region, BG also 3 region. So probability 10 out of 36. 0, 1, 2, 3, 4, 10. 10 ways to get 3 region. So 5/18 answer. All these are my rough work. So we stop here today. Finish already.